In this video, we are going to simplify how to solve series and parallel circuits. In this problem, we are told to get the total resistance R sub T and also the current through the 3 ohm resistor. Now before we look at that, I want to take you through the basics. Let's start with series arrangement. This diagram is basically a representation of resistors in series. Now I want us to use some tricks here, and the tricks are really amazing. We shall call this point A. The next point, which is this one, shall be our B. Then this shall be our point C, and lastly this one shall be our point D. Now notice that between A and B we have this resistor R1, between B and C we have R2, and lastly between C and D we have R3. I want us to represent this in a line form. So we shall write A, B, C, D in a line. Then notice that between A and B we have resistor R1. So we shall have here R1. Then between B and C we have R2. And lastly between C and D we have R3. Now notice that it is basically possible to represent this in a line because it is a series arrangement. Now for a series arrangement, the total resistance is given by R1 plus R2 plus R3 up to Rn. Now another thing that is very important that we must master under series arrangement is that the current in a series arrangement is normally the same, but the voltage divides. Now let us look at an example for this. We have this arrangement and we shall use our same trick. We shall have A, B, C, D. Then we shall write A up to D. So we begin with A, B, and between A and B we have a 2 ohm resistor. Between B and C we have a 3 ohm resistor, and between C and D we have a 5 ohm resistor. R total, or basically the total resistance, is given by R1 plus R2 plus R3 all the way up to Rn. Since we have 3 resistors, we shall have this. So we shall have 2 plus 3 plus 5, and this gives us a total of 10 ohms. And this is basically our total resistance for this arrangement. Remember we've said that the current is normally the same for resistors in series. So this means that when we get I, it is normally the same for all of them. From Ohm's law, we know that V is equal to IR. If we make I the subject, then we shall have I being equal to V over R total. Our V is 20 volts and our RT is 10 ohms. This means that we get our I as 2 amperes. To get the voltage drop through each resistor, we multiply I and R. For the first we shall have 2 by 2, that is 4. For the second it shall be 2 by 3, which is 6. And for the last we shall have 2 by 5, which is 10. And when you add all these values, you notice that we shall get 20 volts. Let's also look at parallel arrangement. And this is a basic representation of resistors in parallel. For the formula, it shall be 1 over RT is equal to 1 over R1 plus 1 over R2 plus 1 over R3 up to 1 over Rn. Then these also are very important. The voltage for a parallel arrangement is the same, but the current divides. Now let's try solving for this example. Write the formula, and this is basically our formula. Since we have 3 resistors, we shall have this formula up to R3. So this shall be 1 over 4 plus 1 over 5 and plus 1 over 20. When we add a quarter plus a fifth plus 1 over 20, that gives us a half. At this point, many students actually make a mistake. This is 1 over RT. So we need to get RT. And to get RT, we do the reciprocal over half and we get to ohms. Then from Ohm's law, we know that V is equal to IR. So to get I, or the total current from the source, we shall have 20 over the total resistance, which is 2. And 20 divided by 2, we get 10 amperes. Now let us get the current through each of the resistors, and they should add up to 20. So for the 20 ohm resistor, it shall be 20 divided by 20, that gives us 1 ampere. Then for the 5 ohm resistor, our voltage is 20 and the resistance is 5, so it shall be 20 over 5, which gives us 4 amperes. Then last, for the 4 ohm resistor, we get 5 amperes. Notice that 5 plus 4 plus 1, that gives us 10 amperes. Now let us go ahead and solve this problem. Since we've understood the basics of the series and parallel arrangement, so the first thing, we shall call this point A, this B, this shall be point C, then this shall be point D, then this shall be our point E. But notice that between E and D, there is nothing. So this means that this point will still be point D. Then last, this shall be our point E. Now the next thing is to represent this in a line. So we write A, B, C, D up to E. Between A and B, we have 4 ohm resistor. Between B and C, we have the 6 ohm resistor. Then between C and D, we have the 6 ohm resistor once again. But you notice that we also have B to D, and there are 2. So we shall have them in this form, the 8 ohm resistor and the 12 ohm resistor. Last, between D and E, we have the 3 ohm resistor. Now to simplify this, you notice that these two are in series. So we begin by adding the 2, and that gives us 12 ohms. Then from there, you notice that from our examples, these are in parallel. This means that 1 over RT shall be equal to 1 over 12 plus 1 over 8 plus 1 over 12. And when you add this, you get 7 over 24. Now this is 1 over RT. To get RT, it shall be the reciprocal, which is 24 over 7, and that gives us RT as 3.4. Now then you notice that we are left with this arrangement, and these basically are in a line. So these are in series. So we just add 4 plus 3.4 plus 3, and that gives us RT as 10.4 ohms. Now at this point A, you notice that we have our voltage as 24 volts. From Ohm's law, we know that V is equal to IR. To get I, it means we shall have our V, which is 24, over our RT, which is 10.4, and that gives us 2.3 amperes. And in a series arrangement, the current is normally the same. So this means that all of these will have 2.3 amperes as the current. And so our R sub T, or our total resistance, is 10.4 amperes, and our current through the 3 ohm resistor is actually 2.3. And this is basically how you can simplify this easily. Hopefully you've understood the concept. Then go ahead and like this video, comment, share, and don't forget to subscribe to this channel. Thank you for watching our video.